Hi there. I hope you're all safe and doing well. And thank you for joining my keynote session on Couchbase Autonomous Operator for Kubernetes, a globally distributed cloud native database. A quick introduction about me. I'm Anil Kumar, Director of Product Management at Couchbase. I'm responsible for our flagship product, Couchbase Server, Couchbase on Kubernetes, customers running Couchbase on cloud infrastructure such as AWS, Azure, Google Cloud, and Alibaba Cloud. Here are some of my big accomplishments in Couchbase for past 8 years. I'm also a published author of the book Couchbase on Kubernetes. With that, let me get started. One of the most innovative and personally fulfilling jobs that I have done in Couchbase in last few years is to establish Couchbase as a cloud native database. So the vision I'm going to talk about in this keynote presentation is so how did we become a cloud native database? What was the strategy? How we executed on the strategy? And what are the product capabilities we have built in the product? And finally, I'll also talk about the key benefits to the customer. So vision is to become a cloud native database. So what is cloud native? So if you look at the cloud native definition from Cloud Native Computing Foundation, it talks about cloud native technologies empowering organizations to build and run the scalable applications in a modern dynamic environment such as public, private, and hybrid clouds, utilizing the key ingredients of the technologies like containers, service meshes, microservices, immutable infrastructures, and declarative APIs to exemplify this approach. But if you look at the pillars of the cloud native, it has four pillars, which is DevOps, continuous delivery, microservices, and containers. DevOps is all about the collaboration between the software developer and the IT operations with the goal of constantly delivering high quality software that solves the customer challenges. And when you look at the continuous delivery, the goal here is to be speed of delivery, which is the faster time to the market. In this case, it's enabling the agile product development practices. It's about shipping small batches of software to production constantly through automation. And the containers are the key ingredients. Containers and Kubernetes is how this is actually possible to do the DevOps and continuous delivery. Then there is microservices, which is the modern way of building the application from the legacy, the old way of monolithic application to the more modern microservice architecture. Right? For a application to be a cloud native application, that needs to be in all those four pillars, and that's precisely what we have done in Couchbase. We are basically enabling our Couchbase to be a cloud native, being part of the DevOps continuous delivery. We are containerized and we work with microservices. Right? So for the DevOps, the challenge we had before was the DevOps had two different target architectures, two different platforms in terms of development, in terms of deployment. Database were on the legacy systems like on-prem or VMs versus the applications like stateless applications were all containerized and in the modern architecture, modern platforms. And so there was a impedance mismatch between these two target architectures and the platforms, which created a lot of issues for the DevOps in terms of the deployment and managing and stuff. So how we solve this is by bringing the stateless and stateful into the same target architecture, in the same platforms. With our integration with the Kubernetes, now your both stateless and stateful application can run on the same platform. And also for this continuous delivery, for the applications, increasingly there has been an adoption of the continuous delivery tool sets such as Helm charts. And so it's packaged and deploys across multiple environments and go to the production. And so it's the full automation of the life cycle. Right? And so we decided to create a Helm chart for Couchbase so that it can be part of that tool chain. Right? It can be part of that continuous delivery pipeline. And the database changes can also go along with the application changes, the different environment and to the production. We were the first NoSQL database to production certify running a database on containers, right? And so our story of containerization it goes back to 2015, and I'll talk about it in a bit. And we work with microservices, and that has been our whole reason why we even started working on the containerization of Couchbase is mainly for the application developers who were in the journey of modernizing and adopting microservice architecture. Their use cases for running database closer to the microservices for performance, for data governance and data sovereignty is why we wanted to enable the microservice architecture. So now let's take a look at our strategy. How did we become a cloud native database? And how did we be part of those 4 pillars I was talking about? How are we part of those 4 pillars? So the way we identified that we can become a cloud native is adopting the cloud native technologies. And there is and if you look at CNCF landscape, you will find there are hundreds of projects, open source projects, and in each of those different categories, there are some of the projects are incubating, some of the projects are already graduated. For example, in case of scheduling and orchestration, you'll see Kubernetes has become a de facto standard. It is a graduated project. Likewise, on the monitoring, you will see Prometheus has become a de facto standard and graduated as the graduated project. So what we did is we looked at what is needed for the database to become a cloud native, right? So if we have container orchestration, we have monitoring, we have logging, we have networking, security. And so we started picking the open source project, which have become a de facto standard, and we started building a backbone for our Couchbase, which is a cloud native. We started building this cloud native backbone for the Couchbase. And so that is what we're calling it as a cloud native database. Right? So to give you an example, we started with Kubernetes in 2017 is when we started working with the building a native integration with the Kubernetes, which is a container orchestration. And then for monitoring, Prometheus was emerging at the time, and now it has become a de facto standard. So now we have a native integration with Prometheus for monitoring and monitoring across the multiple Couchbase clusters. And we have a Helm chart for Couchbase for package management and deploying across multiple as part of the continuous delivery. We have open tracing. We are also have come out with the Couchbase Service Broker API, Couchbase Service Broker. So we can see that we are actually utilizing this cloud native technologies, these open source projects, and building our stack or our backbone for Couchbase, which is a cloud native database. So I'm going to now spend more time talking about the execution, or how did we actually execute it and what product we had built. And so, as I said earlier, it started with Kubernetes. It started even before Kubernetes, it was with containers. And with Kubernetes, we actually created a separate product line for Couchbase. Right? And that product line is called Couchbase Autonomous Operator. So to give you an overview about the autonomous operator, I want to first talk about a journey we have taken so far. And this is important because if you look at in 2015, there were customers who wanted to run Couchbase on container technology. There were 3 main use cases for running Couchbase on container initially. 1, it was package it once and run anywhere. Number 2, to efficiently utilize system resources in their development and test environment. Number 3, it was to run small size workloads, which are not mission critical in production. Although we production certified running Couchbase on containers in 2016 with Couchbase Server 4.5, there were many challenges, limitations which customer faced when they started running Couchbase on containers in production. The challenges they faced were containers are stateless, right? And they needed support for persistent storage for complex distributed database, which is in this case Couchbase. They wanted to run Couchbase clusters with a lot of orchestration with being efficiently run and also resilient, and then also supporting in case something goes wrong, they wanted it to be supportable, like be able to diagnose the problem. So there were a lot of limitations when they started deploying Couchbase in production on containers. And that is where, with our evaluation, we found out that we need a container orchestration to efficiently run a distributed database on containers. And so we started working on building a native integration with Kubernetes. And in August of 2018 is when we launched Couchbase Autonomous Operator, which is a separate product line from Couchbase. And the whole purpose of the Couchbase Autonomous Operator is to provide a fully autonomous cloud enabled platform, Kubernetes based platform for users who wants to run Couchbase on containers and Kubernetes. Right? So and from 2018 to now, we have launched multiple minor versions, and also we launched a major version this year in April 2.0. And we are very close to releasing our next version, which is 2.1, which is coming shortly in next couple of months. Right? So as you can see, there's a journey we have taken from 2015 to all the way till 2020. And so you can see the maturity we have got in the product. And if you go to operatorhub.io, which is a portal for all the operators which are built, you'll see the Couchbase is all at the maturity level of 5, which means that we have some of the basic features to advanced and more advanced features like auto scaling and auto scaling features which are coming in the product. Right? So it's the history of what how journey we have taken so far. So let me give you a quick overview of what this autonomous operator is, and then I'll talk about the product capabilities we have built. So to give a very simple definition of operator, it is a special type of a controller within the Kubernetes. And this controller is built for, its application-specific controller for Couchbase. So this controller knows how to run Couchbase lifecycle, its entire lifecycle efficiently. So just imagine the best practices guidelines we've been giving to the customers. We took the same best practices guidelines and we have automated those best practices through the operator, right? And so now provisioning, self-healing, upgrade, backup, RBAC, cross data center replication, all of those operations which traditionally the DevOps or administrator used to do, that are all automated with the operator. So let's take a look at the architecture. So if you look at the architecture, there is Kubernetes cluster, which has its own master, and there are different components within the master. And there are two main blocks within in this architecture diagram. One is the admission controller, and then there is autonomous operator. The admission controller is again shipped from Couchbase. And this is more of a validation and more of a protecting users from making any misconfiguration and taking these putting the changes to your production cluster. So it will basically, its job is to protect and make sure that the configuration you're passing on are validated, and then it gets applied on the Kubernetes cluster. The Couchbase Autonomous Operator, on the other hand, that is one which is responsible for the lifecycle management, creating the pods, creating the resources, and also self-healing, upgrade. Everything is taken care of by the operator. And there is Couchbase cluster, to give an example, which is deployed in a user-defined namespace. And when you deploy the Couchbase cluster for data, for search, index, analytics, those services, we need a persistent storage. So that all is managed by the operator. Creating the persistent storage, creating the persistent value claim, all is managed to the operator. And I talked about Prometheus for monitoring. So we have the integration with Prometheus, and this applies to any clusters. Like if you have 10 clusters running in the same namespace, and you want to send all the stats from those 10 Couchbase cluster to the Prometheus, you can visualize through the Grafana dashboard. You have a centralized single pane of glass. You can monitor all your Couchbase cluster from the Grafana dashboard, and that's possible with Prometheus now. Going into the more specific, talk about like what actual product capabilities were shipped in the Operator 1.x, and then also I'll talk about what features or capabilities were shipped in 2.x later on. So in August of 2018, when we launched 1.0, I'm going to talk about some release defining features. These are really some important features. There were hundreds of other improvements made, or some more small features, but I'm going to focus on some release defining of big features. The automated provisioning was the biggest one, which is like to make it easier for users to customers to go deploy a Couchbase cluster on the Kubernetes platform. That was the number one goal, right? With a single click or a single command, you would be able to create a 10 node cluster or 20 node cluster or 100 node cluster deployed across multiple zones utilizing the multi-AZ deployment, deployed on different pods with the different resources, all through one single configuration, right? And that was the goal, which was to simplify and deploy the Couchbase cluster with one single command. The auto recovery feature was, this is another highly beneficial feature. One of the unique thing about the Couchbase cluster running on the containers is, if you saw my architecture diagram, you will see that the compute and storage are separated out. So the Couchbase instances are running on the pods, but then the data which is getting stored is on the persistent storage. So now, let's say if the pod, which the Couchbase instance, which is running on a pod on a host, if that host dies and if I lose the pod, my data is still intact. So what operator does is it will bring a new pod on a different host and it will attach to the persistent storage. And then we do a delta node operation, which will catch up the data from where it left off and then bring it back to the capacity. So the whole time to recovery or like self-recovery process is reduced significantly now. You don't have to do rebalance operation. You don't have to do massive data synchronization of the data, because now your data is still intact in the persistent storage. The pod, which the instances, Couchbase instances, which died, comes back. Now you reconsider the data, we can get back to the cluster. So this was a very important, crucial feature for from the point of like self-recovery and then time to get back to the cluster. So on-demand scaling. So the idea here is like you have thresholds set, you have alerts set for your different stats you're looking at, and when those thresholds are hit, you want to scale your cluster, or you can scale up, or you want to scale down. You can do all of that through the single command on the configuration. So you can change the value on the configuration. Operator will go scale up or scale down. We did production certify Couchbase on the autonomous operator on the open source Kubernetes and Red Hat OpenShift. So we have been part of the Red Hat OpenShift from the version 4. Before even 4.0. The 3.9 is when we certified, and 4.0 we are actually built. The operator is actually built into the Red Hat OpenShift now. We then shipped a minor version with some enhancements to the supportability for log collection and log retention. And in last year, we shipped a 1.2 version of the Couchbase Autonomous Operator. And this release is fully packed with some really advanced features. The number one feature there, which I'm very passionate about, is the automated Couchbase upgrade feature, which is this was a number. So when you look at the upgrade process itself, typically depending on the size of the data, number of nodes within the cluster, the upgrade process can take from days to weeks or even months. Right? So it's a long process, and you want to make sure that your upgrade is fully completed to go from one version to another version. So this was a lot of pain point for the customer, because they have to be glued to the screen to make sure that the upgrade process is going through. They will write scripts, they have to automate it, they have to manage those scripts. So there are a lot of those pain points. And so we wanted to take away those pain points. And so we decided to automate the whole upgrade process. And so we, with the autonomous operator, now upgrade process is fully managed by the operator. So if you want to go from the Couchbase versions 6.0 to 6.6, it's a single command for you. So this was handled properly. But then we realized that the Couchbase cluster itself is running on the Kubernetes platform, and the Kubernetes itself is getting upgraded every quarterly, right? So the Kubernetes version comes up every quarter, and most of this cloud managed Kubernetes services, they update the Kubernetes version. When the Kubernetes cluster itself is getting upgraded, what happens is the worker nodes which are getting upgraded, they need to be taken out of the rotation, they get upgraded and they come back. So when that happens, you don't want your database to be disrupted. So we wanted to handle that situation also. So we decided we have now upgrade, we have automated the whole process of Kubernetes cluster upgrade process. So when the Kubernetes cluster gets upgraded, we utilize the Kubernetes functionality called pod disruption budget to make sure that the Couchbase cluster doesn't get impacted. We have security features for the TLS, like the TLS to secure communication between the nodes within the cluster, between the cluster via XDCR, and also between the client and the server. We also decided to production certify the Couchbase Autonomous Operator on the public cloud, cloud managed Kubernetes services such as AWS EKS, Azure AKS, and Google GKE. There are increasing number of customers who wanted to run the Couchbase cluster and Couchbase operator on the cloud managed Kubernetes services. As I mentioned earlier, we have a Helm chart for Couchbase, much easier to put it in your continuous delivery pipeline and automate the whole life cycle from there. There's also an important feature from the development perspective. If I'm an application developer and I'm doing a development on my Mac or Windows desktop, but my database, my Couchbase cluster is deployed on one of the public cloud Kubernetes services such as EKS or AKS or GKE, I should be able to connect to my Couchbase cluster. And this public connectivity feature enables you to do that. So now I'll talk about what's new in 2.0. As I mentioned, the 2.0 is a brand new release, which is a major release which happened this year in April. So there were a lot of other operations which we did not automate in the 1.x, which were like security, backup, monitoring, and everything. And so we decided to do that in the 2.0 major release. So the RBAC, which is providing the role-based access control for your Couchbase, creating the users, assigning them the roles, was a step which was done manually before. Now with the operator, you have a separate configuration file where you define the users, define the roles, and the operator will go and automate the whole process for you. We also support LDAP and LDAP groups. Similarly, the backup was done manually using a jobs in the past. Now the operator can manage the creation of the backup, scheduling the backups, and also providing the visibility to the user on the backup operation itself. So a lot of financial customers or the healthcare customers, they want to audit those backups. And so their requirement was to make sure that when backup operation is run, either it completes or fails, we want to get notification or we want to get visibility into those backup operations. So we have done that with the operator now. So and one more thing here is when you create a backup through the operator, you can you can schedule it on a persistent storage, and you can define where the persistent storage are. Like if you're deploying it in on the cloud, your persistent storage can be on a different availability zone, so you can protect your data from any disaster like that. So there are a lot of those best practices guidelines. So one of the thing which why this release was a 2.0 and not a minor release is because when we have a architectural change in the product, that's when we call it as a major release. And so this was a big architectural change in the way the Couchbase operator was built. In the 1.x, there was only one role and there was only one security user, and that was cluster manager or cluster administrator. So this cluster administrator was, he would create the Couchbase cluster, he would define the topologies, he defines the pod resources. So there was one single user who would do that. But increasingly, we started finding out that we need a fine-grained control over the different resources which are getting created. If I'm in big organizations, they have a user administrator, they have a XDCR administrator, backup administrator, and they have responsibility to control the resources which they are creating. So with this operator security model, you have separate configuration files for each of those users, and the resources they create is all managed by that user. And so this operator security model is big change in the operator 2.0 release. Monitoring and alerting, I think I explained earlier, which is like now we have a integration with Prometheus. So the stats from different Couchbase cluster can be published to the Prometheus cluster. And from there, you can set up a alert manager. You can also have a Grafana dashboard to visualize and have a single pane of glass. With the alert manager, you can configure alerts for the Couchbase cluster and get notified when those thresholds are hit. Cross data center replication is mainly for high availability. For any mission critical application, one of the requirement is to have a high availability cluster, which is like, you want to have a cluster, geolocated cluster in case of a catastrophic disaster. So in this case, before in the 2.0, the cross data center replication was manually set up by the user. Now XDCR, they have, as I said, there is a user for XDCR, and he can configure which data needs to be replicated and what subset of the data can be filtered out to that cluster. So that all can be defined in the configuration. An operator will take care of creating the replication stream and configuring them. There are many customers who were utilizing our sync gateway for the edge computing use cases, and they wanted to run both the Couchbase cluster and sync gateway on the Kubernetes. And to make it easier for them to simplify the whole deployment process, we created a similar configuration files for sync gateway. So you can utilize those configuration files to deploy the sync gateway along with the Couchbase operator. And so the whole process of deployment can be simplified. And so this is for mainly the customers who have the edge computing use cases or mobile use cases. So that's all we had. And as I said, these are all the release defining features we shipped in 2.0. Now I'm going to talk a little bit about what's coming in the 2.1 release. And again, I'm going to talk only about some release defining features. So auto scaling is one of the highly asked feature from many customers. And the goal, as you can see, is it's like, hey, I want to auto scale my cluster when I need more capacity, and when I don't need it, I want to scale it back, right? So this was a requirement. Typically, it's a big if we scale up and scale out, scale back. So there's a heavy cost of rebalance operation. You have to move some of the partitions to the new nodes, and then when you scale back, so you have to rebalance it again. So that is network dependent. That is there are a lot of resources associated with that. And so for that reason, we wanted to take a phased approach. We didn't want to enable the auto scaling for stateful services, although we can, but we decided to do it in a phase. In the 2.1 release in next couple of months, we will be having we'll ship a feature for auto scaling of stateless Couchbase services such as query service or ephemeral bucket, where you set a threshold, and as soon as the threshold are hit, the operator will go and scale up those query services now. Eventually, in the next release, we will also enable the auto scaling for stateful services like data, index, search, analytics. There we need more intelligence. We also need to make sure that when you scale up the data service nodes, it doesn't impact your SLAs like performance and stuff. Usage metering was another highly asked feature. Most of the big organizations wanted to understand how much usage has been done. They wanted to get a fine-grained details about the usage so that they have better idea of the cost when they are running it in the public clouds. And so this usage metering report provides them a complete granular information about the usage consumed for Couchbase cluster and Couchbase operator. So as I mentioned earlier, so the backbone for the cloud native and some of those open source projects, and one of them in this case, the networking wise, Istio and NY has coming up on the networking side, mostly with the microservices. And so we wanted to make sure that we enable customers who are in the journey of modernizing and utilizing these technologies. So we started support for Istio and NY on the operator in the next release. There's also the Couchbase Service Broker. And the idea here is to even further simplify the whole process of deploying the operator and Couchbase cluster itself. And today we have a YAML file, and we give it the user takes this YAML file, puts those configuration, deploys the operator first, deploys the Couchbase cluster. And so now with the service broker, there is a further simplification. So all those steps can be abstracted away. And there's a single service, just to give an analogy of the AWS services. So you will have a service and there's a plan. And when you click on this plan, it gives you a different parameters to fill. And once you fill the parameters, and you can go deploy it on any of your environments. So it further abstracts and simplifies the whole deployment process. And so it will be a feature which will be one of the feature which will there are a lot of enhancements we can plan to add in the future releases. Like we'll simplify further adding more advanced level capabilities into the service broker. So I talked about all of the product capabilities, and I promised about key benefits to the customer. So from the customer perspective, if you think about the cost, right? So there is a cost reduction up to 30% by providing business agility to migrate seamlessly between the cloud providers. The customers can run Couchbase cluster on any cloud, including private cloud with Red Hat OpenShift and public cloud such as Amazon Elastic Container Service for Kubernetes or Azure AKS or Google GKE. And from the developer's perspective, there's a productivity increase of like 90% by removing the impedance mismatch and self-service access to the database. Well, they can also standardize on the development, test, pre-production, and production environment. And from the DevOps perspective, the operational cost has been reduced by 90 to 95% by deploying and running Couchbase as a service, as a containerized stateful application next to their stateful applications. So this gives you an idea of like how the cloud native, being a cloud native database, can provide so many benefits in terms of the developer, in terms of empowering the developers, business agility, and the operational cost. There are a lot of happy customers, and there's like the list is keep on growing. In this case, Bipin Jetwani from AT&T, they did a beta testing for Couchbase Autonomous Operator 2.0. And you can see from the codes, which is like the features keep the DevOps deviation at the bay, no fuss around backups, no hunting for right Prometheus exporter. And so it's like that kind of feedback we have been hearing for the autonomous operator. And also there are other customers like Staples and CenterEdge and BD Health who have provided the codes and feedback for the product. With that, I'm going to end my session.